Good morning, students. In thermodynamics, I'm going to explain this concept. What is the relation between enthalpy and internal energy? It is the board exam, very important question for the 2 marks question. 2 marks question it is, 2 marks compulsory. The board exam very important for the board exam. They are asked the previously so many times. The question will ask what is the relationship between enthalpy and internal energy. Very important. In this year also they asked one question from in this formula. Based on this formula they asked 2 marks question. This year also they asked the question. That is a very carefully you have to listen. Now the relation between enthalpy and entropy. Now we know formula of enthalpy formula, that is H is equal to E plus PV. For according to statement, the heat is equal to sum of internal energy is added to some product of pressure and volume. From this equation, this is the equation for the enthalpy. In this equation, from ideal gas equation, PV is equal to nRT. Now in this case pressure is constant, these are the constants. Now in this equation volume change, that is we can write as V2 minus V1. Now N also will change, N2 minus N1 into RT. That's when we can write as PV, P delta V we can write here, delta nRT. Now we know the formula. Change in enthalpy delta H is equal to delta E is equal to P delta V. Now P delta V is equal to what? We can write as N delta RT. Delta H is equal to E plus delta N RT. This is one equation. Also we can relation between enthalpy. This is the formula we can use for the relation between enthalpy and internal energy formula. We can calculate this formula some questions. Now delta H is a change in enthalpy, change in internal energy, change in number of moles. RT is a constant. Now in this case delta H is called as heat of reaction at constant pressure, and delta E, the heat of reaction at constant volume. H is the constant pressure. Now delta H is at constant pressure, but delta is at constant volume. Now we can write as from this statement. Now N delta N, it is a coefficient of gaseous of product minus coefficient of reactants. Now in this case we can write delta V is equal to 0. Now then P delta V is equal to N delta N RT. Now it is become 0, means N delta RT is equal to become 0. Now this value substitute in this equation. This equation will become delta H is equal to delta E, it is equal to E Q. Because of it is become now 0, it is equal to 0, and when delta V is equal to 0, now become 0. Now we know already change in enthalpy plus change in internal energy plus then delta V and delta RT, delta RT nRT, that is the, now it become 0 from the equation because of delta V is equal to 0. Now it become 0. Now enthalpy substitute the 0 become the changes delta H is equal to delta E plus in place of this one 0. Now we can write delta H is equal to delta E is equal, there is a Q, total heat and energy. Now one more that condition under standard condition, under standard state when temperature is 298 kelvins, comma pressure is 1 atmosphere, all the species present are at unit activity. They are unit means 1. Now we can write as that is standard condition delta H naught, the equation become delta H naught delta E naught plus N delta RT. It is a standard condition. The formula will be changed into delta H naught delta E naught and delta N RT. It is a standard conditions. Now this is the formula also. We can use for calculation of standard conditions. They given standard condition, the question they ask, we can use the formula is, this is the formula we can use for the standard conditions. Delta H naught is equal to delta E naught plus N delta N RT. Now here T is equal to, we know, 298 Kelvin, and R we know that is the standard values 8.23 kilojoule per mole.